And we're live. Hello, everyone. We're back. There we go. Focus better. We're back in another video. But first, how do we sound? How's the sound of this live stream? Is it good? Is it a good sound? Hold on. I think it's pretty okay, right? It's not too bad. You guys can hear me fine. And that's what's going to be on. Got like something here. But it's totally okay. I don't know if you'll notice, but if I turn off the lights, I think we can see some light of this desk. Yeah, no, I don't think you guys can see it over here. But I turn off the lights. It's kind of fun like that, isn't it? We could probably turn them on later. But no, in fact, I guess I'll just turn them on right now. I don't know. I actually don't know what works best, but everyone, uh, welcome back to another live stream of doing calculus. And if you're not notified about yesterday's live stream, we are now doing calculus 2. So there's a whole nother level of difficulty for this one. Yet it's actually pretty cool. It's pretty cool because now for birthday, we got an iPad and we're doing a bunch of math in here. We just did the substitution rule yesterday and it was a tough 3 hours, yet we got through it. And today we are doing integration by parts. We are doing integration by parts. I think people say that this concept of Calc 2 is harder. However, no, I didn't see it was very hard compared to what we did before. And yes, that's what we're going to be doing. I don't think we have anything else to say. We can probably just share our screen right now because why not, right? I mean, like, why not share the entire screen? Very cool. We're back in business, everyone. We're back in business. I want to see if there's any unnecessary tabs we have. Yeah, we probably don't need that. We need that open. Okay, and this is for object-oriented programming. We can live stream that later. But awesome. I love this. Let's do this. The homework has begun. So I'm going to open my beautiful iPad. I love you. It's fine. Very cool. You just need to clean it. Let's see that. Oh, very cool. So then we do that. Oh, that's actually kind of cool. But hold on. What if we just do a photo? That's a photo, right? Photo. I take a photo of you guys, right? Awesome. Hope you all didn't mind. All right. So let's get working because there is a lot to do today. Let's go to our whiteboard. So before this live stream, I was watching a lecture and I was doing some integration problems. So here are the notes for the integration by parts. We derived the entire formula simply by looking at the product rule for derivatives. It was pretty cool. I'm not sure if it's necessary to cover it. And yeah, we did a couple problems. As you can see, it was pretty cool. I'm not sure if you can see well. And now we are going to begin. We're going to begin doing problems again. It would be cool if we could share our screen, our iPad screen, also in here. That would be pretty cool. However, that probably proves to be a little difficult, so I think we'll just go on with what we have to do. Looks like we have 15 problems. So it's not 26, so that's pretty cool. However, I'm guessing the problems here are going to be a little tougher. So use integration by parts to evaluate the integral. So we have an indefinite integral of x times e to the power of 4x dx. So, if I recall correctly, I believe the formula goes something like the indefinite integral of u dv equals to u v minus the integral of v du. I believe that's what it is. Let me just write this clear. V du. I believe that's how it goes. Now, okay. So our first step, we have to choose a value for u. So how do we do this? So we can say u equals, let's see. So we got to choose a value for u that will make the derivation of that value simpler. So if we choose e to the power of 4x, we will get 4 times e to the power of 4x. And that obviously does not make it simpler. But if we make u equal to x, then if we apply the derivative to x, we will get something much simpler. So we could say that u equals x. And therefore, we will say that the rest, that means e to the power of 4x dx, that's going to be dv, I believe. Hold on. That's going to be dv, right? Because we want to get all of this, all of our integrand into a form of u dv. So we already chose u, so now it's time to choose dv. And we said that it should be e to the power of 4x dx. Very cool. So now, because we also need to have, we need to know what du is and what v is, then we will apply the derivative to du and integrate dv. So let's do that. So du dx equals 1. The derivative of x is 1. And then we isolate du, and we get 1 times dx or dx. Very cool. So that's simple. We know that. Now we need to apply the derivative to dv because we need to know what v is, and that's how we get v. So we apply the derivative to e to the power of 4x dx. The integral of dv is going to be v, and the integral of e to the power of 4x dx, well, let's think. What applied to the derivative to will be e to the power of 4x. Let's see. Well, I believe it's going to be e to the power of 4x over 4, because if we derive that, we get e to the power of 4x. Pretty simple. Very cool. Okay, so we have everything. U equals x, v equals e to the power of 4x over 4, dv equals e to the power of 4x dx, and du equals dx. Very cool. So now we can simply just apply the formula. So we know that the integral of x times e to the power of 4x dx, well, that's going to equal to u times v, so that's going to be x times e to the power of 4x over 4 minus the integral of v du. So that's going to be the indefinite integral of e to the power of 4x over 4, and then du, and we said that that's dx, so dx. So we have x times e to the power of 4x over 4 minus the indefinite integral of e to the power of 4x over 4 dx. uv v du. Yes, that's correct. So now it looks like we just got to do the easy part, what we know. We just got to simplify. So, yeah, I don't think we can simplify x times e to the power of 4x over 4. So I'm just going to write that again. But then we of course must integrate e to the power of 4x over 4 dx. So how do we do that? So what's the integral of e to the power of 4x over 4? Well, that's going to be, oh, that's a good question. What applied to the derivative to will be e to the power of 4x over 4? Is it e to the power of 4x over 16? Yeah, if you apply the derivative there, you'll get, yeah, I think that's correct, unless I'm mistaken. Very cool. And I believe that's, oh, of course, we missed the plus c. Well, let's type that in, right? 4 minus e to the power of 4x. Let's go. Let's go. I mean, I just begun learning this concept today. I really had no idea what it was. It's actually not as hard as people say. Let's go. Okay. That's actually not bad. I'm glad. I'm glad that it's going well right now. Let's keep going. That's one problem. Let's try to go faster than yesterday because it was tough. Yeah, it was not even that bad. Okay. So we have the integral of 3x times cosine of 5x. So clearly here it looks like it gets a little harder because not only do we have two functions in the integral, now we have a composition of functions in the cosine of 5x. So it seems like we're going to have to use not only integration by parts for the product rule, but then we're also going to have to use u substitution. So that's something to look forward to. So first, let's think, what will be u? If we let u be cosine of 5x, and we know that we need to integrate u, will it make it simpler? Not really, because if you apply the derivative to cosine of 5x, we get 5 cosine of 5x. Is it simpler? No. So if we apply the derivative to 3x, we get 3. Is it simpler? Yes. So we should let u be 3x. And now for dv, because remember, we want to get the integral in the form of u dv, okay? dv, what is dv? Well, dv, we can't really choose. We already chose what u was, so we choose the rest. dv is the rest. So since u is 3x, well, dv is the rest. It's going to be cosine of 5x dx. Very good. So now, because we are going to derive u, we want to know what du is. We don't have that here. We are going to apply the derivative. So we have du dx, since it's in terms of x, equal to 3. That implies that since we need to isolate u, du equals 3 dx. Very cool. So now we need to find what v is, and we do that by integrating dv. Hold on, I'm just going to wipe the screen. It's crazy how many dust particles are in the air. Very cool. We must have a clean iPad, you know. So the integral of dv equals the integral of cosine of 5x dx. So the integral of dv is v, exactly what we're looking for. And the integral of cosine of 5x, well, here is where we use u substitution. What is u substitution? Well, it looks like we've got to use a value for u. So it looks like a good value for u will be, whoops, that's kind of ugly. A good value for u in this case will be 5x because that's the inner function. That's the value you want for u in u sub. So what's next? Let's see. Cosine of 5x. I think we only have one variable for u substitution. I'm just trying to remember how to do u substitution. Oh boy. I did 26 problems. How did I forget? Let's see, bro. How do you do this? Hold on. U equals 5x. That's for sure. Hold on. How do you do u substitution? That's incredible. We spent 3 hours and a half yesterday. How did we forget how to do u substitution? Let's see. Let me just remember how to do this. So they're telling us, all right, choosing u is not the hardest part right now because we just chose u. Here u equals to the square root of x. Can you write the integral in terms of u? Don't forget about the differential du. The differential du is 1 over 2 times square root of x. Now, how do we find that? Du dx is square root of x. That's wrong. Du dx is what's du dx? I'm so stupid. So square root of x is x to the power of 1/2. And the derivative of that is 1/2 x to the power of negative 1/2. There we go. 1/2 x to the power of negative 1/2. X to the power of negative 1/2 is 1 over square root of x times 1/2. That's 1 over 2 times square root of x. All right, boom. That's what we have there. Oh, and then du, we multiply dx both sides. We get du equals 1 over 2 times square root of x dx. Very cool. You can write the integral as, okay, that's the original integral. You take the 3 out. We have, okay, we put it in a single line, like the opposite of a fraction. Sine of u times 2 times du. Oh, that's right. Since du equals 1 over 2 times square root of x dx, well, we replace 1 over 2 times square root of x dx with du. Since we only have 1 over square root of x, not 2 square root of x, we multiply by 2 both sides. So we get 2 du equals 1 over square root of x dx. So since we do have 1 over square root of x dx, we replace that with 2 du. Very cool. So then we take the 2 out of there, multiply by 3, that equals 6. And we have sine of u du. We evaluate the integral, and then we replace. All right, I think I understand. Still seems very weird to me. Looks like I need to get much more practice. But it's okay, because we are doing what we have to do. So u equals to 5x. So now I'm just going to write, we have 3x cosine, whoops, no, that's not what we want. Cosine of u dx. So du dx is 5. Thus, du equals to 5 dx. Can we replace that here? Oh boy, oh, this is harder. How can we replace 5? Oh gosh, bro. Well, looks like we're gonna have to divide by 5 and multiply by cosine. I don't know if that makes it easier. All right, this clearly looks a little bit more complicated. How do we do this? I mean, I know we chose the right u in the first place. So u equals 5x. Du dx is going to be 5, right? Du equals 5 dx. 5 dx. How do we replace that there? I don't think we can do that. Okay, hold on, pause. We have du equals 5 dx, cosine of u dx. Let's see, think. Well, let's see what happens. So if we have du divided by 5 equals dx, I guess we could do that actually. I mean, Huh. Yeah, du equals 5 dx. Du over 5 is dx. So we can just replace that, right? I mean, like, why am I doubting? Let's see, let's see. You know, I think that's good. So that means to write it in terms of u, we got to do, let's see, cosine of u, du, all of that over 5. Okay. So what does that mean? Right, so we replaced that, but we still need to do the integral of that, right? So that's why we will do the integral of cosine of u du over 5. Oh, whoops. Yeah, du, right. We take the 1/5 out of there. We have 1/5 integral of cosine of u du. Oh, okay. I think that's simpler, right? Unless I'm missing anything. Equals well, yeah, just antiderivative of cosine of u. That's going to be sine. So sine of u du. Sorry. No, yeah, no, you don't put the du. So it's the sine of u. Let's go. So, and then I think we replace, right? So 1/5 sine of u. And what's u? We put u equals 5x. Sine of 5x. All right, let's check if we got it right. The derivative of all of that is going to be it's going to be 1/5 times 5 sine of x, or just sine of 5x. That's stupid. We get 1/5 times 5 cosine of 5x. In other words, we cancel the 5's, that's cosine of 5x. Let's go, we got that right. Okay, all right, cool. So, in other words, v equals 1/5 sine of 5x. That's okay, awesome. Let's go. We're cooking. So just now replacing u, v, dv, and du in our integration by parts formula, we get, so we have uv. So first we have 3x times v, 1/5 sine of 5x, minus the integral of v du. What's v? V is 1/5 sine of 5x. And then du, it is 3 dx. Cool. So simplifying a little further, we get 3/5 x sine of 5x minus, and the integral of 1/5 sine, are you sure that it is 3 dx? Yeah, du is 3 dx. Very cool. So the integral, we have another, no, that's not another product. Oh, we're good. 1/5 sine of 5x, the integral of that. So do we have to do another u substitution? Let's see. I think we do. So I'm just going to move this all down here because this might take a little longer than we thought. I'm just going to erase this. So minus the integral of 1/5 sine of 5x 3 dx. So simplifying, we get and we can take out the 1/5 in 3, so 3/5, right? Cool. And now we're only left with the integral of sine of 5x dx. Cool. So what does that mean? So sine of 5x dx, what's the integral of that? So we will use u substitution again. So first we will let u be 5x. So now we have sine of u dx. And then we have du dx equals 5. That implies that du equals 5 dx. our third step. What's our third step? Cool. So now we got to replace. We need to balance the integral. 5 dx. Well, we also know that du over 5 is going to be dx. Very cool. Hold on. Dx, right. Du over 5 is dx. Du over 5 is dx. Oh, so just replace, right? So now we get sine of u over 5, and we get dx. We get dx. And the integral of that, so that equals to 1/5 integral of sine of u dx. Really easy, 1/5 negative cosine of u dx, replacing u there back again. We get, and simplifying, we get negative 1/5 cosine of 5x plus c. And so to check our answer, we can apply the derivative again. We get negative, the derivative of cosine of 5x is negative 5 sine of x. The negatives cancel, the 5's cancel, we get sine of 5x, and that's exactly what we had in the beginning. So we're good. So what we do now is simply simplify. Sorry, we just replace that answer. So ultimately, our answer is 3/5 x sine of 5x minus 3/5, and then our answer from the integral, which is going to be negative 1/5 cosine of 5x. And then that plus c stuff, which they already have it there, so we won't have to worry about that. Simplifying even more, 3/5 x sine of 5x plus 4/5 cosine of 5x. All right, I really hope I don't get this wrong because this took a while. Yet I understood everything that was going on, so that's cool. Oh boy. All right, well, it's okay. It's okay. Totally okay. Let's see what we got wrong. So first, okay, let's see. So we have 3/5 x sine of 5x minus 1/5 sine of 5x 3 dx. Where do we get the 3dx? 3dx, that's du. So we have v du. 3dx, yeah. That's u. Gotcha. So hold on. Oh wait, I see. So we have 3/5. Oops, I spit in my tablet, dude. So we have 3/5. We take that out. Okay. So we have 3x 1/5 sine of. Oh boy, what am I saying? Oh, okay. So we have uv, right? What's uv? U is 3x. V is 1/5 sine of 5x. Oh, hold on. We have 3x over 5. That's not the same thing as 3 over 5x. Three x over 5, right. Hold on, wait, pause. Oh, dude, what am I doing? 3x. We have uv, so we have 1/5 sine of 5x. 3x, okay. I don't think that's different, but oh wait, hold on. So do you just want me to like oops. mean, I swear, if that's the case, okay, phew, at least it's not the case. Um, let's see. Maybe it was something we did here. Oh, it's multiplication. That's why. Negative 3/5 times 1/5. All right, I'll just do minus a 3/5. Okay, all right. Probably did like a dumb algebra error right there. By parts might be easier. Oh, rather than using U substitution, do you mean? Oh, let's see. Where did we use a U substitution? We used it for sine of 5x dx. I mean, we don't have like any product of functions. I don't see how we can use by parts here. Are you are you referring to like another to another part? All right. We'll keep that in mind. I'll see when I can use by parts then. Let's see. Well, let's keep going. We got two questions. We're doing good. We're doing good. We just gotta sit up straight. Oh, thought the pencil was gonna fall for a second. Let's go. Let's keep going. So use integration by parts to evaluate the integral from 0 to pi of 3x sine of x dx. Hold on, why am I holding it like that? Whoops. Let's see. So first, let's think of a value for u. U equals, I'll make my pocket, bro. U equals, so if we apply the derivative to 3x, derivate, whatever, we get 3. That's simpler. And sine of x, we get cosine of x. I don't think that will help us. So u equals 3x. dv equals sine of x. So that's our u dv. Now we got to find values for du and v. So du dx equals 3 and du equals 3dx. The integral of dv equals the integral of sine of x. Oh, let's go that we have a simpler one here. The integral of dv is v, and the integral of sine of x is going to be negative cosine of x, because negative cosine of x, the derivative of negative cosine of x is negative sine of x, and that's sine of x. Cool. Oh, it was that simple? Okay, so now we just apply the formula, I guess. So uv is 3x times cosine of x, uv, right? Wait, u dv. Hold on, why does that look awfully familiar? That's weird. Oh, sorry, negative cosine of x. There we go. That's negative cosine of x minus the integral of v du. What's v du here? So negative cosine of x times du, and du is 3dx, so 3dx. So we have negative 3x cosine of x and the integral of negative cosine of x 3 dx. Wait, negative. Hold on. So we have There you go. Let's see. We can take the -3 out, right? I mean, if you have 3, you can just take it out. So negative plus 3 times the integral of cosine of x. Whoops. We can do that, right? I think so. But if there's an error, I ought to come back to here because I might have done something wrong. The integral of cosine of x, that is sine of x. So we have -3x cosine of x plus 3 sine of x plus 3 sine of x plus c. It's not defined. There you go, right? What's wrong here? Oh, this is a definite integral. Oh my gosh. I gotta look out for those. So what do I do? Okay, hold on. Oh wait, hold on. So do I just, that's probably wrong. Where's pi? Here, pi minus -3. Oh, so 0 cosine of 0 is 1, I think, but that's still doesn't matter. And all right, 0 plus 0 is 0, so -0. I think that's good. Very cool. So it looks like the only thing we had to do was apply the fundamental theorem of calculus. We evaluated the indefinite integral, or like the antiderivative, but we forgot to do antiderivative evaluated at pi minus antiderivative evaluated at 0. And I think that's okay, right? I mean, like, I don't think we missed anything. Very cool. Question 4. Let's not stop. We're doing good. We're doing good. So we have the integral of natural logarithm of 7x plus 9 dx. So how do you do this? I don't know. We'll see. Interesting. So we don't see any product here. We see like a composition of functions. But I found this technique where you can do, hold on, what do you do? Is it u? Yes. So u equals natural logarithm of 7x plus 9 dx. Sorry, not without the dx. And therefore, dv must be equal to 1. Oh, sorry, dx with u, right. So therefore, du, here, I'll be right back. Just gotta. Let's go. We got some breakfast right here. Shout out to brother and dad for this beautiful breakfast right here. Almost got very cool. So, do by parts should be sine of 5. Wait, hold on. By parts, yes, right. Should be sine of 5x. U is 3x. Hold on. I think this for, yeah, U is 3x. By parts, we got, hold on. I'm sorry. Are you referring? Oh, wait. This one. Yeah, U is 3x. V is sine of 5x. I got 1/5 sine of 5x. Because, oh, well, right. If I do the derivative, I'll get sine of 5x again. And then dv is cosine of 5x, dv. Yes, that's also what I got too. And then du is 3dx. Awesome. All right. Or matching. Thank you, man. Yeah. I I guess I did another method then, since you said you used by parts. But cool. No, I mean, looks like we got the same thing. Let's go. And by the way, thank you for your help. Thank you. These suggestions always help. There was a time where I was stuck in a problem. I had no idea what to do, and this guy came up and gave me like a super simple solution, and I understood right away. So, I mean, any help was appreciated. Really, I'm just a newbie at this, so please, if you have something to say, please tell me. Anyways, so du. This is gonna be. Oh, whoops. Wait, hold on. Du dx. Du dx is going to be 1 over 7x plus 9 times 7. So I can put that in. And this implies that du equals 7 over 7x plus 9 dx. Cool. Hold on. Well, let's look it up. And we need to know, oh, we also need to know v. So the integral of dv is the integral of 1. Therefore, v equals, wait, what's the integral of 1? Is that x? Wait, okay, I'm sorry. What is a variable? V is a variable. So v equals v. Wait, I'm sorry. Oh, in terms of x, I think. So x, right? X, yeah. So if that's the case, wait, hold on, pause. Wait, dude. Wait, I need to use u substitution though. Hold on. I need to eat more. Huh. I mean, I don't have any product. Oh, okay. Well, it looks like I'll still have to use a u substitution. Okay. I'll just go ahead. So we have the what happened? I don't know. Wait, this happens a lot. There you go. So the integral of natural logarithm of 7x plus 9 is dx. Sorry, dx equals uv. So ln of 7x plus 9. Here, I'll just equals ln of 7x plus 9 v. What's v? X. And then we have minus the integral of what? Of v du. There you go. So x and du, which is 7 times 7x plus 9 dx. Very cool. I'm just gonna drink. That's good. That's good. I feel like I'm doing something wrong. I mean, we should use u substitute. Okay. Okay, so I'll do it this way, and then I'll do u substitution. But we also have two functions there. So, all right, here, let me use u substitution. So I'm just going to move it down here. Whoops. The integral of the natural logarithm of 7x plus 9 dx. So if we let u be 7x plus 9, because why not, right? Du dx 7 plus that du equals 7 dx. So if du is 7 dx, yep, no, that's possible. I don't even know how I'm going to get from 7 dx to a natural logarithm of 7 x plus 9. All right, I mean, I'm tempted to press help, but I feel like we can do this on our own. U is 7x plus 9. Hold on. Oh, so was I in the right track then? Was I doing it correctly, or I'm kind of confused? Wait, where did I? Hold on. 7x plus 9. Okay. So should I use by parts first or u substitution? Which one should I use first? I'm kind of confused. Here, if I put get help. Can you integrate by, okay, so first we use integrate by parts, letting u be the natural logarithm and dv, okay, so I think I was in the right path before. I don't think we use u substitution first. I'm just gonna Let's go. Looks good to me. Okay. Perfect. We were in the right path here. So I'm just gonna erase all this. But I ate a big bite. Right. So how do you do that? Oh, hold on. Let's go. Oh, there we go. All right. So that's what we have. Should we split this into two fractions or what? Oh, or multiply by the conjugate. That's also a good idea. I'm just gonna. Okay, I'll do that. So now we can split the fraction, right? Minus 1 over 7x plus 9, right? Dx. So this equals 2. Very cool. Oh, easy. Okay, then things get a little easier. Gotcha. So how do we integrate that? So what we can do is 1 minus 1 over 7x plus 9, which is actually pretty easy. Oh, hold on. No, it's actually very easy. So the integral of 1 is going to be x in respect to x. I mean, since we're in, there you go, minus, and this is basically just natural logarithm of 7x plus 9, all of that, over 7x plus 9, I think. If we take the derivative of that, we get 1 over 7x plus 9. Oh, wait, no, hold on. It's it. So the natural logarithm, but then it'll be times 7x plus 9. So we got to divide by that, right? Right. There you go. So we were right. And then, yeah, we just integrated, but we need that. Plus c, and this is plus, right? Oh, wait, no, times 7. Whoops. Right. 7. Sorry, over 7. There we go. So looks like, oh no, that's good, right? Makes complete sense. So we have the natural logarithm of 7x plus 9 minus x plus the natural logarithm of 7x plus 9 over 7. With the plus c, that looks good, but it's not. What did we get wrong? Oh, whoops. Hold on. What's this x doing here? Yeah, we forgot the x right here. That's also wrong? Hold on. Was it like a sign mistake? It probably was a sign mistake, wasn't it? Minus x plus that. So minus x, right? Okay, hold on. What did we have before? We had the natural logarithm of 7x plus 9. Well, yeah, we put 9, right? X times x minus all of that. So we split that into two integrals, minus the integral of 1 plus the integral of that, I think. The integral of 1 is going to be x, so we have x minus x plus natural logarithm of 7x plus 9. All right, hold on. What did we get wrong? I hate to do this, but so what did he do here? Yeah, that's exactly what we have. X times natural logarithm of 7x plus 9 minus x plus 1/7 ln of 7x plus 9 plus c. So looks like we factored, what did we factor? We factored ln of x. Okay, so do you want us to simplify? Oh, and in fact, if we put x over here, does that make things different? Bro. 7x, ln. You know, although this is equal. Bro, what's going on? Do you want us to simplify? X ln of 7, x plus 9, minus x plus 1/7 ln of 7x plus 9. Hold on. Dude, what is going on? I swear, dude, what am I missing? Dx, right? So we have x times ln of 7x plus 9 minus x plus ln of 7x plus 9, all of that over 7. X ln of 7x plus 9 minus x plus ln of 7x plus 9 over 6. Why is this wrong? Dude, I literally have no idea what. Okay, that's it. Time to ask generative AI because there's literally. New chat. Why is my answer wrong? Nine sevenths. Hold on. Why 9/7 though? That's 1. What did we do? 9? Oh, interesting. 7x over 7x plus 9. That's what we had, right? We split that into, sorry, we added 9 and then we subtracted 9. So we had 1 minus, and we subtracted 9. That's right. So since we subtracted a 9, not 1, that's weird. Why did we do 1? When we subtracted 9, we had 9 right here, 9 right there, 9 ln. That makes sense. That's why. Gosh, dude. Gotta be careful. So let's go on. Wow, that's a bunch of integration we have already done. Let's go. Oh, we're cooking, guys. Oh, we're cooking. Okay. So this looks okay. An hour, okay. Incredible. We've already done an hour? Interesting. Cool. Let's keep going. I'm gonna drink a little bit more. Let's do this. Okay. So first, what is u? Let's see. Hold on. So what do we have to do again? The one that can simplify when we apply the derivative. Right. So if we do arctangent, we get 1 over square root of, no. Sorry, 1 over 1 plus x squared. I mean, it looks like it'll, okay, what if we do, let's see. It's a good question. I mean, I think I'm kind of forced to do arctangent though, because that's the only term we have. But u substitution would tell us something different. All right, let's just see what we can do. dv equals dt, right? So du dx equals 1 over 1 plus 9t. So this is actually 81t squared times 9. And therefore du is, come on, bro. Dx. Very cool. And now, oh, and we need to find v2. So the integral of dv is the integral of dt. So v equals t. Cool. So just putting all these variables in, we get uv. So arc tangent of 9t. Hold on. And now I'm meeting. Oh boy. Okay. Arc tangent here. I'm just gonna write it down. And then v, so arc tangent of 9t times t minus the integral of v du. So t times, oops. What happened here, dude? Times 9 over 1 plus 81 t squared dx. I hope I'm not doing anything wrong. I kind of feel like I am, though. Let's keep going. So we have, yeah, so arc tangent, let's say the same. Dude, what's going on? This equals 2. So, whoops. By the way, and this is t. Why was it repeating? Hold on. T squared over 2. T squared over 2. Okay? T squared over 2. Oh, but this is a multiplication. One plus 81 t squared. Yeah. Okay, so wait, whoops, and by the equal. Wow, dude, I'm losing my mind. There we go. 9t over 1 plus 81 t squared dx. So, oh, cool. Okay, no, we actually might be going in the right direction. So let's see if we split. If we split it, we could. Wait, no, hold on. Huh. Let's get some help, shall we? It's always good to ask for some help. Cool. Okay, we did that. We had a good instinct. Oh, awesome. Yeah. So wait, why dt though? Wait, pause, pause, pause. Oh no, no, we're good. We're good. T times arctangent of 90 equal, and then here. Oh, whoops! I put dx. Oh, that's not good. Right, dt is the dummy variable, not x. Okay, so what is the next step? So you factor 1/8 Whoa, where did W come from? Let's see, let's see. Interesting. So they're introducing a new variable. Oh, U substitution, of course. Gotcha. Cool. Okay, so of course. So let's do just that. So let's say that U equals, let's see, what should it equal? Let's see, think. I mean, it's hard to pick a U. Oh, oops. I mean, it looks like they picked U for, I don't know, 1 plus 16t squared. All right. And 1/8. Okay. So let's see. How do they do this? That's probably the hardest part. Bro, hold on. So 1 over W. What did they let W equal? So 1 over 8. So that means if the numerator was left untouched, then 1 plus 16t squared. All right, come on, bro. Let's see. Um, let's think. Okay, I think I'll have to ask. Oh, okay. Right, yeah. Oh, cool. Okay. So if that's the case, then all right, let's go back here. So we have, so use that. So we have the integral of, what do we have? 9t over 1 plus 81t squared dt. So then this will equal to 9t. In fact, this can be um, 1, what's 81 times 2? 81 times 2 is 162t, and that implies that du equals 162t dt. For real? I think so. 90, 99, 108, 117, 126, 135, 144, 153, 162. Interesting. Okay, so we have u over here. U. dt. Right. Yeah. Hold on. Pause, dude. So we want to replace 162t dt with something to do with du. Oh, sorry, du. So 9t over 1 plus 81t squared. Um, 9t over 1 plus 81t squared dt. Think. So, oh, no, it's going to be this hard. Hold on. So 162t dt, right? Um, how, dude? Hold on. So if du is 32t in their case, so we rewrite 4t. 4t. Huh. So u equals 1 plus 16t squared. Then du is 32t dt, right? But the numerator is only 4t dt. So rewrite 4t dt as 1/8 du. 4t dt. Oh boy, come on, dude. It shouldn't be this hard. We have more problems to do. We gotta keep going. Um, so we have 162t dt, right? Dude, why am I so like confused? Oh boy. Hey, what's up, dude? How are you? Yes, yes, I did a stream yesterday too. Today I'm stream. Excuse me, I'm streaming again today. Yeah. Thank you for being here, dude. But I'm just trying to understand how they used U substitution here. So, if U equals the denominator 1 plus 81 t squared, right? Then we have du dt, and we get 162t. And that means that du equals 162t dt. Uh, oh, I see. So we need to get the numerator to 162t, or what? Take. But the numerator is only 4t. Hold on. So, yeah, du is 32t dt. We divide by 8, both. Oh, gotcha. That's interesting. A very good way to see it. So, hold on. That's 18. That's 18. So, du over 18 equals 9t dt. Right. Yeah. So, oh, and since we have here 9t dt, 9t dt, then we can replace all of this with du over 18. So we have du over 18 right here. And that equals 9t dt. Right, so we could replace all of that with du dt. And we have here 1 over 1 plus, or actually 1 over u. 1 over u. That simplifies to du. Hold on. Or yeah, or 1 over, okay, so 1 over 18, the integral of 1 over u du. There we go. Makes complete sense. And we can finish this off. The integral of 1 over u is ln of absolute value of u. Very good. So we go back here. I think we're good. That's our answer. ln of absolute value of 1 plus 81 t squared over 18. So we put that in here. Cool. We put that in. Arc tangent of 9t times t minus ln of absolute value of 1 plus 81 t squared over 18. Let's go. Let's go, guys. Whoops. That was a tough problem. That was a tough problem. Okay, we're 1/3 of the way there. Oh boy. You know, we're doing good. And I'm excited. Oh. Oh, okay. We have streamed for 1 hour and 20 minutes. Are you guys tired? I don't think I'm very tired, but I'm starting to feel it a little bit. Cool. Thanks, guys, for the emojis. I appreciate it. Let's see. We're 1/3 of the way through homework. So that means we're not finished. Let's do this, guys. We got this. So we have to evaluate the indefinite integral of e to the power of 7x sine of 7x dx. So the first thing we do, u, what does u equal? Well, let's see, which simplifies better. So if we take the derivative of e to the power of 7x, we get 7e to the power of 7x, not that cool. However, if we take the derivative of sine of 7x, we get sine of 7 sine of 7x, so non-simplify. So what do we do? Well, oh boy, so it's like 50-50, right? Let's see. Okay. What do we do? Looks like a good day outside, I'm not gonna lie. Let's see. What do we do? Scooby-Doo. Oh, I mean, I don't want to press get help. However, I don't want to be stuck in this forever. Let's see what they do. You can choose either factor of the integrand, yes, as u. Right, that's the thing. They both simplify, they both don't simplify very nicely. So we can choose anything. All right, cool. Let's do. Oh boy, is it glitching? Should we do another page? Okay. And dv will be anything else. What's dv? Well, it'll be e to the power of 7x. So du dx is going to be 7 cosine of 7x. And thus du equals 7 cosine of 7x dx. Very good. And then the integral of dv is the integral of e to the power of 7x. Very easy. V equals e to the power of 7x over 7. Because if you apply the derivative to e to the power of 7x, you get e to the power of 7x. Sorry, if you apply the derivative to e to the power of 7x divided by 7, you get e to the power of 7x. Awesome. So now we continue. So uv, you and me, what the heck am I saying, bro? Sine of 7x times e to the power of 7x over 7. And then we do minus the integral of v du. The integral of 7x, e to the power of 7x over 7 times, du. What's du? 7 cosine of 7x dx. So this looks a little longer. So how do we do this? Looks like we will have to, oh, no, I see. Gotcha, okay. Both of the terms in the function of the integrand are a composition of functions. So for both of them, we will apply u substitution. So we got to be careful here because there can be a bunch of errors. So, cool. No, okay, that's it. Come on, bro. We got to focus. Let's do some 10 push-ups. Very good. Very good. We're ready. We are ready to continue. So, let's see. What do we do? Scooby-Doo. Let's see. Okay, no, actually, we kind of have everything well. So first I'm just going to put sine of 7x times e to the power of 7x, all of that over 7. And then we will later put our integral. Let's go. So what's the integral of e to the power of 7x over 7 times, oh, well, would you look at that? The 7's cancel. I didn't notice that until now. E to the power of 7x times cosine of 7x dx. That makes it much nicer. Ooh, let's go. Let's go. In fact, I'm just going to get rid of that negative there. No, yeah. We get it, actually. So e to the power of 7x. What is that? So, do we do integration by parts again? Oh, hold on. Pause, bro. Looks like we need to do that again, right? But nothing will simplify nicely. We will just go in loops. What happens if I press enter? You know, it's not going to work, right? Yeah, obviously. Let's see. Wait, what do you mean attempt 1 of 2? I have limited attempts. Let's see. Do we have to use integration by parts again? No, but I don't think so. So how do we do this? Right. Right, we will need to do integration by parts again. Let's go, guys. We're doing good. We're doing good. This time it matters that you let u equal cosine of 2x. I wonder why. Because if we do that, we do negative 2 cos... hold on. No, we do 2 sine of 2x. That's not simpler, is it? Okay, maybe something will cancel out. So let's follow that. So u equals cosine of 7x. Therefore, dv equals e to the power of 7x dx. du dx equals the, equals negative sine of 7x times 7, and thus du equals, I mean assignment created, that's weird. Du equals negative 7 sine of 7x dx. Gotcha. And then we got to integrate dv equals the integral of e to the power of 7x dx. It implies that v equals e to the power of 7x over 7. Very cool. So now after applying integration by parts, again, Why is it so? There we go. That's much cooler. Um, I believe we get so UV, so we get cosine of 7x e to the power of 7x over 7 UV minus the integral of v du. v du. What is v du? E to the power of 7x over over 7 times du. What's du? Times negative 7 sine of 7x dx. Gosh, bro, this is getting long. Now, what's next? Well, we simplify. So, will we have to apply it again? You have du equals negative 7 sine of 7x dx, and v equals e to the 7x over 7. Right. So, so yes, okay. And this simplifies. Right. Can you combine this result? We're not done though. Oh, what? All right. So we get. So if I combine that to what we had before. So we have. Sweep all of that. How's that going to help us though? Oh, actually, will you look at that? Hold on. So. Why is it minus though? Hold on, pause. Um, shouldn't it be a plus? Um, So he applied it. Oh wow. Integration by parts once again. So we get well, how did okay, I'm confused. Let's see, bro. So it looks like he applied integration by parts again. Once again. And did we already do this one? Okay, so how do you play again? So u. What did he choose? U is cosine of 2x. uv. Bro, uv. Let's see. So cosine of 2x over 7. We want why we what? How? Why do I have a sine and he has a cosine and he have a cosine? What? He has a cosine. Oh my gosh, dude. What? This problem is so long. Got lost. What are we doing here, dude? What happened? So I have this, right? The original integral is the hold on, but I have a why do I have a cosine and he has a sine? Oh come on, bro. What happened now? Um the original integral. Okay, so I have this right now. Cosine of 7x, and we solve that integral. Oh, and we get this cosine and then with a sine. Perfect. Yes, makes sense. And then the original integral was This. Oh, I see. Cool. Uh-huh. So sine. Yup. Wait, hold on. Wait, what? So this equals the sine. Wait, cosine. Oh, right. So this right here equals cosine. Uh-huh, half. This equals that minus the full one. Uh-huh. But why? I'm wait, okay, so this, right? No, no, no. This equals sine minus cosine. Right. And it's full. That's right. Okay. That was the original integral. Now, here we have a half, but then a full one. Right. That's exactly what we have. So let's rewrite this. So we have hmm? So we have whoops, it's too thick. There you go. Awesome. We're back in business. So we do. Okay. Minus then our entire integral right here. Okay, good. But for some reason, phew. I thought I had it wrong. So this is just a plus. That's right. Very cool. Okay. So that's what we have. Okay. So now here, how do you simplify that? Equals. All right. So it keeps this the same, right? You can't do anything that we already integrated. Okay. And then minus cosine of 7x. And then plus the integral. One, two. Wait, why minus the integral? Oh, because the minus is distributed, right? Very good. So now here comes the hard part. Oh, so he I see. Gotcha. Oh, that's right. They are the same thing. I understand. So what we do, now we get 2 times the integral of e to the power of 7x sine of 7x dx equals sine of 7x times e to the power of come on, bro. Over 7 minus cosine of 7x e to the power of 7x over 7. That's what you have, right? Perfect. And then we divide by 2. Okay. Oh, plus c. Wait, why plus c all of a sudden? No, I'm not going to add that plus c. It makes no sense. Why do you all of a sudden just add a plus c? That's weird. Whatever. Well, that looks good to me. That looked like a very complicated problem. I don't exactly understand how I would be able to come up with all of that. But who knows? Maybe we do enough practice and we can do a problem like these on our own next time. Okay, that was like 35 minutes for a problem right there. We go an hour and 48 minutes. Maybe we should play Minecraft, right? I agree. Let's play some Minecraft. Yeah. Let's play some card games, should we? Let's see. Let's do this one. Play now. 6,000 people are signed up here. Wow. That's it? Okay. No, that's fine. Can we Minecraft in here, dude? It's cool. What else games are we have? Fortnite. What if you play like a simpler game? Oh no, I don't want to download anything. Come on. Snake games. No, I mean, actually, this is calc. I'm just taking a break since we've done an hour and a half, or more like an hour and 15 minutes. Here, let's call ourselves poop, because why not? Oh no, we lost. Oh, these guys are super long. They're so big. Oh, let's go. Look at all this food we have, guys. Oh, and somebody else died. How? No, he died. No, we had a bunch of food. Darn it. But this game is actually fun. Could it be funner than Calc? No, no, I don't think so. Calc is pretty fun. But this game does look pretty fun. Bro, you can do that? Yo, let's go. No, no. Oh, crap. Bro, the reaction time is very slow. Yo, let's get this food. Let's go. We're in 20th place. Yo, let's get all this food. Yum, 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 yum. Oh, let's go. That's super satisfying. There we go. Look at all of that. Look at all the food we have. All right. We got to be careful, though. We're in 9th place, and we're in the leaderboard. Let's go, guys. Oh, he died. Yo, let's get all this food. Let's get all this food. Look at all of that, guys. Guys, look. We're in 3rd place. Let's go. Let's go. Huh. Oh, we trapped a snake inside. Ah, he died. Here, I'll make like a big circle. There we go. And that's very cool. Phew. Almost out of there. Let's go. Our circle is huge now. Yes, even more. If I speed up, do I lose a lot of health? Phew. Come on, guys. We can't lose. Let's go, guys. Poop is in third place. This is so fun. Yep. Okay. Oh, gosh, dude. Oh, yay. Oh, guys, this might be the first place guy. Oh, yay. We got more food. Yes. Let's go. Let's go. And we're so big that people are spawning in us now. Let's go. Who's this? All right. I guess it's okay if we break our circle now. Yo, look at all this food. We have 6,000 now. We're in second place. Let's go, guys. We're so good at this. We have 6,900. I will try to go to first place because why not, right? If you're doing calculus, you better get first place. Yo, who died? Oh, this guy. Cool. Ooh, more food. Look at that. We got another person inside here. Oh, and he died. Here. It's kind of getting boring. So, am I first place? You guys? Oh, okay. I was first place for a second. Yo, let's just get that food and then let's go fight some people. Who's this guy? Pinhead Mike. We can't let him surround me. Another person died. Oh, let's go. Let's go. Let's go. Let's get all this food. Okay. Oh, what? I thought I just saw him die. We have 8,000. In first place, that's 13,000. We need to get more food. Whoa, what's all this food? Let's go. We have 9,000, guys. Very close to 10,000. Whoa. Are you guys seeing this? What? How did that happen? Oh, okay. Well, that was fun. That was fun. But I believe it's time to get back at it because that was cool. Well, I am going to go to the bathroom, and then we will continue. Okay, let's resume. Let's resume back to doing some calc. Let's clean our tablet because see there's some dust in it. Gotta have a clean tablet if you're gonna do some clean algebra. Come on, bro. All right. Okay, cool. Oh boy. Hmm? What happened? Oh, great. Can you like take a screenshot? There we go. Come on, dude. How? Oh, great. Very cool. So we can get rid of all of that. Cool. Okay, everyone. Here we go. Next item. Hopefully it isn't too hard. Let's see. So we have this. 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 Okay. Oh. Oh boy. Guys, we've been streaming for 2 hours and 10 minutes. Probably doing math for an hour and 50. Cool. So let's evaluate the integral. And this is a definite integral. Oh, and it's for 1. Let's see. I don't know how we're going to do 9 more problems, dude. Oh, boy. No, it's fine. We will do them because we can. So first, what will be u? X to the power of 8 will simplify in ln of x. Probably won't. So let's say x to the power of 8. Is that what you do? Oh, hold on. Hold on, why? Oh, because it gets more complicated. I see, I see. Cool. No, no, no. Okay. Makes sense. So dv equals x to the power of -8. So therefore, oh, whoops, and this is dx in terms of x. So dx right here as well. So, du. So du. What's du? So du dx equals 1 over x. And therefore, du equals 1 over x dx. Good. Now, the integral of dv equals the integral of x to the power of 8 dx. Therefore, v equals x to the power of -7 times 1 over -7. And that equals to negative x to the power of -7 over 7, or -1 over 7x to the power of 7. So v equals to -1 over 7x to the power of 7. Looks good to me. So now, doesn't seem as if we need to apply u substitution because we don't have any composition of functions. But what we will do is we have to do. I don't know why I'm just yapping over here. So 1 over 8 x. So we're going to do the, whoops. Perfect. So now, wait, and okay, cool. So first we have uv. So therefore, ln of x over 7x to the power of 7 minus the integral of v du. So -1 over 7x to the power of 7 du is, what's du? Oh, 1 over x dx. So 1 over x dx. Cool. Dude, what's going on? And we have, cool, looks good to me. I don't know why I'm just hesitating a lot. So, perfect. Why can't we zoom in, dude? This is, okay, hold on, dude. Why is this going on? Um, Perfect. So now, oh, so this is actually super easy. I don't know why we're complicating things too much. Um, that should be correct. Oh, there we go. Wait, e to the power of what is 0? Well, 1, right? So we have 1 over 7. There you go. Well, what do you want me to do? I mean, oh, whoops, and it's not 0, it's 1. Great, guys. Oh wow, I'm getting tired. I'm getting tired, y'all. What am I doing with my life, guys? Come on. Okay. Oh, let's see. So, oh, gotcha. I think I understand my error. So, UDV, right? There we go. So we said e to the power of what is 1? 0. So ln of 1 is 0. 0 to 1 is 0. Gotcha. So we have okay. We're getting somewhere. Plus so first we have x to the power of negative 7. So the antiderivative, 7x to the power of negative 8, x to the power of negative 7. 1 over, over -7 times 7. This equals to negative x to the power of -7, I think, right? Yes. So you have -8 to the power of -7 minus -1 to the power of -7. This equals, okay? And -8 to the power of, okay. Okay, so -1 to the power of -7. This is the same thing as 1 over -1 to the power of 7. Or actually, no. -1 over 1 to the power of 7, -1 over 1, -1. That's -1. Gosh, dude. Does not have to be so complicated. And then, so 1 minus 8 to the power of 7. Very cool. So now we have what? Fine. All right. Simplifying proves to be too difficult. We will just write the raw equation. So what do we have? -1 over 7 times ln of 8 over 8 to the power of 7. Bro. Plus -8 to the power of 7 minus -1 to the power of 7. That's okay. What is going on? Bro, you know what? Dude, I feel like I'm lowering IQ every single time, every single question. What in the world is going on? This should not be so hard. And what is to the power of 7? Where did we get that? We added 1, -7, right. Negative, oh, come on, dude. What's going on? So we're, yeah, -1, 7, ln of 8 over 8 to the power of 7, right? Oh no, don't tell me we made that mistake. Really, bro? Why did we have to do plus? So we have, oh, is that the problem? Dude, I just want to finish this problem, please, bro. But what in the world am I doing? Oh, could that be the problem? Dude, what am I reading? Where did we get the 7? Holy crap, dude. Where did we get the 7? Dude, I'm not doing this again. We spent so much time in here. Where did we get 7 in here? Oh, V. Oh, could that be why? Hold on. So we get negative 1/7. Wait, but that's the thing. I don't think you can do that though. So we get, oh, bro, where am I reading? So first, V, we have V du. What in du is 1 over dx. Hold on. Pause. Oh my gosh, dude, this is so confusing. What are we doing in here? So du is 1 over x dx, right? So 1 over x. Where are we reading? So v, what's v? V is negative 1 over 7x to the power of 7. V du times 1 over x dx, okay? So what does this equal to? Negative 1, 7x to the power of 8 dx. There we go. Dx. Negative 1 over 7x to the power of 8. This equals to negative x to the power of negative 8 over 7, I think. We take the 7 out, so we get 1, 7. And here, from 1 to 8, the integral of 1 to 8, we get x to the power of negative 8 dx. Then x to the power of negative 7. It's ugly, horrible. Negative 7 over negative 7. So we're going to get some help, because this proves to be very confusing. Then we get the 1 over negative 7 out. We get negative 1 over 49 times x to the power of negative 7. Gosh. So, oh, gotcha. Okay. So, this, I didn't even know how we got there, nor am I concerned with it. But we get, don't do that. 1 over 49. Um, 8 to the power of negative 7. Oh boy. This is plus because minus and minus. Minus 1 over 49, 8, 1 to the power of negative 7. Oh, it's not negative here. No, if you put plus here, dude. Well, we look at that. Finally, bro. All right. Let's try to be a little more organized next time because this, gosh. I don't know why this, we gotta complicate things too much. It's really not that confusing. We don't have to. Okay, let's go. We're not even halfway yet. We're 47% of the way there. Well, let's continue because we got to. So the integral from 1 to 4 of square root of t ln of t dt. So we need to evaluate that. Okay, it's 1120. So what do we do? So first, u. What simplifies the best? We have t to the power of 1/2. We will, if we derivate that, we get 1/2 t to the power of negative 1/2. Or we could do ln of t. Are they both equal? Letting u equal ln of t. Okay. Well, cool. So we continue. We continue to do. So now du dt equals 1 over t. That implies that du equals 1 over t dt. And the integral of dv equals the integral of, the square root of t dt. Therefore, v equals, so if t is to the power of 1/2, this is going to be t to the power of 3/2 times 2/3. Boom. That's awesome. Is square root of t a composition of functions? Hold on. The derivative. Yeah, no, it's not. It's actually not a composition of functions. So that's why we don't have to use u sub. So, think. So first, uv ln of t times 2/3 t to the power of 3/2 minus the integral of v du. Therefore, we're going to have 2/3 t to the power of 3/2 du. What is du? It's going to be 1 over t dt. Perfect. So we have that. Now, so yeah, this stays as it is. And the integral becomes, okay, gotcha. So let's simplify inside. So we have 2/3. Hold on. So, oh no, actually cool. So we t like that. So t to the power of 1/2. Bro. This becomes dt. There we go. So therefore, ln of t times 2/3. Why does it keep doing that, dude? So therefore, we get, so we add, so 2/3. So t to the power of 3/2 times 2/3. Oops. That's it. Minus 4 over 6. Wait, hold on. So 2/3 times 2/3. That's going to be 4 over 9. Or 2/3. What's 2/3 of 2/3? That's not 2/3, is it? Where's Desmos? Bro. 4 nines. Oh, that's not 2/3. And is this a definite integral? Yeah, it is. So, hold on. I think about it. So, what was the equation? UV. Okay, perfect. So first, I'll do that. So we have ln of 4. So first, we're going to put these brackets. ln of 4. 2/3, 4 to the power of 3/2 minus ln of 1 times 2/3, 4 to the power of 3/2. Whoops. Perfect. Minus 4 nines. Hold on. Four to the power of 3/2 plus minus 4 nines, 1 to the power of 3/2. Very cool. Very cool. Are we doing good in the comment section, guys? Are we doing good? We doing good? We doing chill? That's awesome. It's good to hear that. Oops, I think this got moved a little bit. Ah. So that this was a cool problem. Let's take a screenshot as well. 4 memories, right? 4 memories. We have 3 people watching. Welcome, everyone. It's good to see you guys all. It's good to see you all. I think I said that wrong. But it's okay because we're advancing progressively in our homework. And this one looks tougher because it looks like we have more than 2 composition of functions. Whoops. So it looks like we're going to have to use, what are we going to have to use? By parts and then u substitution as well. So let's try that. So we have the integral of ln of 3x squared dx. So first, let's choose the value for u. U will equal, what will u equal to? Okay, first, no, I'm not, okay. So they're asking us to do integration by parts. I'm wondering if there are many ways to do this. I just don't know the correct way. Should we do ln of 3x times ln of 3x and then let u equal, no, that's probably going to end up bad. We could do the squared. Okay, let's try that. So what do we do? All right, u, let's try this way. Hold on. So perfect. So okay, that's what we should do. Whoa, dude, look, my forehead there. Oh, not gonna let. It's okay. So then du dx equals 2 ln of 3x. Hold on. Think about this carefully. So du dx equals to 2 times ln of 3x times the derivative of the inner function, 1 over 3x times 3. In other words, we get 6, 2 times 3, ln of 3x over 3x, or 2 ln of 3x. Is that for real? Oh, yes, because here we simply cancel the 3's. Yeah, interesting. Wait, how do we get rid of the 3x, though? Oh, still over x. And we then have, we need to do v. So the integral of dv equals integral of dx, therefore v equals x. Boom. Very cool. So uv, and then v du. v du. What's du? du is, whoa, hold on, I did not, yeah, du is 2 times ln of 3x over x times dx. There you go. Cool. So what's next? So now we need to evaluate the integral. Oh, well, conveniently, the x's cancel. We get indefinite integral of 2 times ln of 3x dx. Oh, very cool. We can further simplify. Minus 2 times the integral of ln of 3x. Oh, okay. What a blessing. Let's go. This one was not as hard. Oh, okay. Scratch that. What is, oh boy, that's a good question. What's the integral of ln? We were so close, guys. Come on. Yeah. How do you do that? Well, not quite, because then we have ln of 4x. Let's see. Okay, so what's the best way to approach this problem? So brackets, okay, I like that. So oh, hold on. Integrate by parts again. Wait, why? Wait, pause, dude. Why do we integrate by parts again? All right, so with ln, looks like we should integrate by parts, or ln in a composition of functions. So here we should let u equal ln of 3x. and thus dv will equal dx. Cool. So therefore, du dx 3 over 3x or 1 over x, and therefore du equals 1 over x dx. And v equals x. Right. Cool. So by integrating by parts again, we get so whoops. So uv, what's uv? Minus the integral of v du. V du. Oh, pretty simple. Okay. So we get ln of 3x times x minus, and here it's simply going to be x squared over 2. So putting this back, we get ln of 3x squared times x minus 2 times, and here's what happens with the integral, ln of 3x times x. Oh, great. Minus x squared over 2. And that's wrong. And I wonder why that's wrong. Hold on. So we have, oh, no. 2 times that, right? Plus, wait, hold on. So x so v du, x times du, 1 over x. And but whoa, sometimes I just don't think, you know? So x times du, what's du? Du is 1 over x dx, or x dx. So we have this first part, minus, well, the x's cancel, we get 1. The integral of 1 is x, so minus x, right? Very cool. Oh, awesome. So x. Let's go. 60% of the way there. 6 more questions. Whew. How long? We've been doing this for 2 hours and 59 minutes. Incredible. Oh, yes? I guess I do remember you. Yeah. Were you the one that, I think we were talking about substitution or something. I don't exactly remember the conversation, but I do remember you. Yeah, man, thank you. Thanks for coming again. It's good to see you. Here we're about to finish 6 questions. Whoa, almost close the live stream. I hope it doesn't take a long time. But yes, I think we did another arctangent question. What was it? Was this one? But this was indefinite. Oh boy, we're getting tired. Let's see. So yesterday we did the substitution rule. Then here we're doing integration by parts. Now we're doing, I think this one's Sunday, trigonometric integrals and substitution. Then we're doing partial fractions, then approximate integrations, and proper integrals. And then we have a review for a test. What's this? Then we have module 2, area between curves, volumes with cylindrical shells, arc length, applications to physics and engineering, sequences, and then another review. Series, convergence tests, power series, functions as power series, Taylor and Maclaurin series, then parametric curves, calculus with them, polar coordinates, areas and length and polar coordinates. Yeah, very cool. Cool. So these are review sections. Okay. And we have reached 3 hours. 3 hours on the live stream. And we're like 60% of the way there. So who knows if we might need 2 more hours, because I don't know how we're gonna do any more, how we're gonna finish this year. Oh boy. Because 3 hours of doing math is a lot of math. Tired, guys. Ugh. But no, we should keep going. Let's do this. I'm going to evaluate the integral from 2 to 4 of arctangent of 2 over x dx. So what is going to be u? Gosh, oh, dude, it hurts. So u. So we have a composition of functions. We're going to have 2 functions. Well, okay, so I think I get it. In a composition of functions, you always pick the entire thing. Am I right? Am I right? I'm right. Yes, guys, let's go. So u equals arc tangent of 2 over x, and dv equals dx, because that's the only thing that's missing. Now, du dx equals 1 over 1 plus, so 2 over x. You square all of that, it's going to be 4 over x squared. And therefore, du equals 1 over 1 plus 4 over x squared times dx. Okay, I see. So, wait, I didn't close anything, right? Phew, we're still here. Du. Perfect. And then, yeah, v will just equal x again. Yeah, so always pick the entire thing when you have only a composition functions. Makes complete sense. Wait. Interesting. So now, uv, we have arc tangent of 2 over x times x minus the integral of wait, I don't think it goes like that, right? Okay, it's fine. The integral of v du. So x and what's du times 1 over 1 plus 4 over x squared times dx. So first, I believe it goes u v from 2 to 4 minus the integral from 2 to 4 of v du. So what does that mean? So uv from 2 to 4. What's uv? Oh, gotcha. Okay, so it's going to be arctangent 2 over 4 times 4 minus arctangent 2 over 2 of 2 minus, okay, fine. Then minus the integral of v du. What's v du? Oh, it's literally just that. Okay, so it's going to be, so let's find the antiderivative of that. Well, that's going to be a little tougher. Do we apply integration by parts again? Let's get some help. You have du equals 3 over x squared plus 9. What? No? How do we get that? So 1 over, oh, I see. I see. Hold on. So 1 over 4. Okay, so it's basically like saying, hold on, I have a question. Nine over x squared. Mm-hmm. Oh, chain rule. Yup, my bad. Sometimes my big blind eyes don't work. No, I was kidding. That's not true. Let's see. So, what does that mean? I have to do everything again, right? Oh, let's see. So, times the derivative of 2 over x. So that's going to be 2 times x to the power of negative 2. That's going to be negative 4x to the power of negative 3. Oh, what is going on here? Here we go. Simple. So we get so complicated, bro. What are we to? Bro, so 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 du dx, what's that going to equal? That's going to equal 1 over 1 plus 2 over x squared times 2 over x prime. Now, 2 over x equals 2 equals to 2x to the power of negative 1. Now, when you derivate that, you get negative 2 times x to the power of negative 2. I think so. Why am I so confused, dude? And this equals negative 2 over x squared. So this equals to 1 over 1 plus 4 over x squared times negative 2 over x squared. This equals to 1 over, or in fact, negative 2 over 1 plus 4. Oh, great, dude. So this equals to x squared plus 4 over x squared times x squared. This equals 2. Negative 2 over x squared plus 4. For real? Yes. Let's go. We did the complex math. Let's go. We did it. Oh, let's go. Let's go, bro. Let's go. So this is our answer. I mean, well, for this part right there, we're like obviously not done though. Very cool. So going back over here. Negative 2x over x squared plus 4 dx. Let's go. Hold on. We already have the first part, right? We do. So we're only doing the integral. The integral right now. And that's what, yes. State. Wait, so we're doing substitution rule here? Gotcha. Okay. So u equals x squared plus 4. Du dx equals 2x, and therefore du equals dx, sorry, 2x dx. So if we have 2x dx, dx therefore equals du over 2x. Yo, okay. How did he do this? Because that looks very complicated. I mean, we should be able to do this on our own, but this is complex, dude. So, right. Choose the substitution. The natural choice is u equals x squared plus 9. I mean, I'm aware that's w, but right now I'm using u. This is because the denominator is x squared plus 9, and the numerator contains a 3x, which is almost the derivative of x squared plus 9. Oh, so we're lucky then, because actually we're so close. We're even closer than them. Yeah, the w equals dx, 2x dx. Gotcha. Interesting. All right. So I need to pay attention to this because this will be on the exam most likely. This pocket just keeps stopping, bro. So we have dx. Hold on. So we have 3 dx So hold on. So du equals dx. Du equals 2x dx. And we need to get it to negative 2x. So we multiply both sides by negative 1. Negative du is negative 2x dx. Oh, okay, let's go. That was actually very easy. Don't know why we complicated that too much, a lot. So now we have the integral from 2 to 4 of 1 over x squared plus 4 du. Since, wait, what? Since du replaces negative 2x. Oh, so, sorry, negative. Negative right there. I see. So here, equal to negative. There we go. Okay. Oh, hold on. And we forgot one thing. What are gonna be the limits? So when x equals 2, u is gonna be what? U is gonna be 8. And when x equals 4, u is going to be 20. So we have 8 to 20. Oh yeah, we forgot to put u. U du. So obviously this is going to be ln of natural logarithm of u minus come on, bro. $20 and 8. So yeah, bro. Oh, that's obviously going to be false. Well, dude, these signs are literally killing me. Whoops, this actually looks like it should be a plus. Yep, okay. So oh, and there's actually maybe like a minus there. Oh, would you look at that? How lucky. Gosh, bro. There you go, 3 hours and 24 minutes. Oh boy. Should we do more? Because we go almost 3 hours and a half. I'm kind of losing my mind over here. Yo, guys, I'm getting tired. I'm getting tired, y'all. Oh boy. We have 5 more questions to finish. That's crazy. I don't know if I can do any more, guys. I'll feel bad if I don't finish. How many integration questions do we have left? 1, 2. It's like 2 other ones, which I don't know how long it'll take. Oh boy. Oh, incredible. Oh wow, 5 people are watching. Let's go. Thanks everyone for joining. Keep it up. Thank you. Thank you very much, guys. Thank you. I appreciate it. All right. Well, because you guys say so, we will finish this. Let's do this, guys. So we have the integral from, oh, it's indefinite. Let's go. So x to the power of 13 times cosine to the power of, cosine of x to the power of 7 dx. So what should u be? U should be studying. X to the power of 13 probably, and dv will be cosine of x to the power of 7 dx. So therefore, du dx will be 13x to the power of 12, and du will equal 13x to the power of 12 of dx. And therefore, okay, no, I mean, not therefore, another one, dv, the integral of dv equals the integral of cosine of x to the 7th dx. Therefore, v equals sine of x to the 7th over 7, I think. Because if you derivate that, you get cosine, you get 7 cosine of x to the 7, and the 7's cancel. Okay, perfect. Beautiful. That actually looks really good. Perfect. So we keep going. Actually, this does not look okay. Well, we probably will have to use u sub. So uv, we have x to the power of 13. Why do we have all those dots in there, bro? X to the power of 13 times sine of x to the power of 7 over 7 minus the integral of what? The integral of what? The integral of what, though? Fine. The integral of v du. So v du. What's du again? Oh. Well, this might take a while. So, oops. Okay, that we keep it at as it is. And I'm not sure. Hold on. So minus 13 over 12. Oops, 13 over 7. So it looks like we must do integration by parts again, I think. Wait, no, we will just keep going in circles, dude. We'll go x to the power of 11, 10, 9, 8, 7, 6. So let's get some help, right? It never hurts to get help. Yes, we did that. Let's go. Oh, well, I mean, come on. You got an easy number. It's okay. Du, I'm sorry. What? Right. So. Oh, what? Oh, wait, you're saying we begin substitution to rewrite the integral. That's tough. When do you use substitution and when do you use in by parts? Okay, well, looks like we'll begin doing a substitution. I like that. Oh, there you go. So we begin doing substitution. U equals x to the power of 7. Du dx 7x to the power of 6 implies that du equals 7x to the power of 6 dx. du over 7. So now we do integration by parts, right? So integration by parts. So we let u be fine. Let's say this is w then. So if we let u equal w. Oh, hold on, wait. But before that, so this w cosine of w, very cool, dx. So if we let u be w, okay. Therefore, du dx. Hold on, what? If u, oh, dv, sorry. I don't know why I'm integrating right now. So if u equals w, and then dv thus equals cosine of w dx. That's u. So du dx equals du dx equals dw dx, right? Implies that du equals dw. That's okay, that's what he got. Right. And then the integral of dv equals the integral of cosine of w dx. Thus, v equals sine of w. Okay. So therefore, now we can construct our integral. So if this is what we have, insert there nicely, you know. So now, so 1/7, right? So right here we have x to the power of 7 cosine of x to the power of 7 dx, right? Wait, what? What are you doing? Oh, great. Bro, what's going on? So what we will do, so we'll go back to our original function. Okay, I see. So we have W cosine of W. So how did I subtract it? Oh, right, integration by parts. I'm so stupid. So, all right. So I do UV. What's UV? W sine of W minus, oops, and this is an integral, by the way, minus the integral of V du. There we go. Close brackets. N plus C. And we replace. Oh, that was easy. Okay. What's W? X to the power of 7. Sine of W is sine of X to the power of 7 plus, bro, don't do that. And dW, what was that? Oh, well, no. We don't need that. Okay. So I think I need to review this problem. Great. Oh, well, that looked actually very weird. That's also incorrect. Oh, okay. Well, now I don't know what happened. Wait, why plus? The antiderivative of sine is negative cosine. Well, if you say so. All right. We go 3 hours and 44 minutes. Oh, you took biology. Cool. Okay. Bio is actually very cool, man. Good for you, dude. Yeah. Oh, thank you, guys. It means a lot. It means a lot, all of you. But we're not done yet because we still have 4 problems left, guys. We're not going to quit. We're not going to quit. Ugh. Huh. And I thought I was going to quit by 1 hour. All right. Well, I'm going to take a screenshot of this. Interesting. Just erase everything, erase everything. Let's keep going. So, the integral from 1 to 16 is e to the power of 4 times square root of x dx. Hold on. You go 3 hours and 40 minutes. Let's go, let's go. Who's this person? I've never seen you. Let's go. Awesome. Substitution as x equals w. Why 1 over 18? 6 squared is 4. 4 times 6, 24. Hold on. Hmm. 1, 4, 16, 4. 4 times 4, 16. Gotcha. Where did he get 1 over 18? I'm so confused. Hmm. Hold on, I'm gonna go to the bathroom. All right, let's do this. Oh, come on, dude. So let's see. So we need to get to something like w squared over, well, in this case, we're gonna have, I'm guessing we're gonna have something like 16. So to get there, what am I supposed to do? Oh, right. So we get what? Fine, a dw. Okay. So what will we let u equal? So I guess we gotta do that w and therefore dv equal e to the power of w dw. Gotcha. E to the power of w is e to the power of w. Right, yeah. So the integral that we know is going to be in, oh, let's go. 4 hours live stream, probably the longest one we've ever done. Let's go, guys. Let's go, guys. So, oh yeah, so UV, right. That, so UV. UV minus integral of integral, oh wait, hold on, this is 4 to 16 minus the integral of what? Of v du. What's du? dw. Cool. Here we go. Moment of truth. Oh, sorry, not yet. So, wait, what's the dummy variable? W. So, this is going to be 16 e to the power of 16. It's 4 e to the power of 4. Minus rho. Oh, and we have to solve. Oh, really easy. Well, that's simply e to the power of w, right? So e to the power of 16 minus e to the power of 4. And that's incorrect. Oh, whoops, we forgot to multiply it by 1 over 18. And that's still 1 over 8, not 18, dude. And that's right. Let's go. We're 80% of the way there. Let's go. Boom. Oh. I want to get some vitamin D, guys. If g of 1 equals -5, g of 5 equals -7, and the integral from 1 to 5 is g of x, of g of x d of x equals -5. Evaluate the integral. Gotcha. So let's take a screenshot of this. Cool. So we know that g of 1 equals -5, g of 5 equals -7. The integral from 1 to 5 of g of x dx equals -5. Therefore, g of 1 equals to that integral from 1 to 5 g of x dx. And we must evaluate the integral of 1 to 5 of x g prime of x dx. Gotcha. Oh, x g prime of x. Oh. What in the world is going on? I mean, I don't even feel tired. I don't even know why we're acting like this. Come on, let's finish this. So how do we do this? So we must evaluate the indefinite integral using integration by parts. Right. So what does u equal? So what does u equal? U equals x, right? X should be a good choice. And dv equals g prime of x dx. Let's zoom out a little bit, bro. Du dx equals 1. Therefore, du equals dx. And the integral of dv equals to the integral of g prime of x dx. Therefore, v equals g of x. Yeah. So therefore, uv x g of x minus the integral v g of x du, which is dx. Beautiful. That's just so cool. Therefore, definite integral first here, it's going to be oh, right, and they're giving us what g of 1 equals and blah, blah, blah. So here we have 5 times -7 minus -5 minus -5. Let's go. It's actually not that bad. So 5 times -7, -35. -35 plus 5, -30 plus 5, -25. Let's go. Oh boy. 2 questions left, guys. Come on. We can do this. We can do this. No, it's not my work. Unless they're asking me Burj Khalifa. We're so close, guys. Come on. So, here, let's do this question first, because it's one we know how to do. So suppose a particle moves along a straight line with that velocity, meters per second after t seconds. It travels blah during the first t seconds. So I think I need to integrate this function. Right. Very easy. So how do you do this? U should equal t squared. Obvious choice. U. dv will thus equal the rest. Du dt equals 2t, and thus we have du equaling, whoops, perfect. And then we have the integral of dv equals the integral of e to the power of 3t dt. And then we have v equaling e to the power of 3t, all of that over negative 3. Awesome. So even though that's correct, I'm not going to check because I think I'm very convinced that I'm correct. So we keep going. What's next? What am I doing? I'm sorry, guys. I just blanked out. My bad. What do we do? What do we do? Scooby Doo. Perfect. So now what we do is very simple, actually. No need to fret. You have UV minus the integral v du. Du. What is du? Awesome. Okay. So simplifying a little bit, we get minus, we get, in fact, we can make this much better. Beautiful. Now let's keep simplifying. Do we do integration by parts again? Yes, yes, we do. So awesome. Oh, I got something here. So first we get 2t. So UV, and then that's going to be, whoops, 2t. Awesome. Minus the integral from, no, it's an infinite integral, so it's fine. Integral v du, v du. Okay, so 2t. Nope, that's not v. Why aren't we thinking? Du. 2 dx, I believe. I hope I'm not wrong. Hold on. Hold on, wait. Du. That's weird. Why do I have an x over here? That's actually weird. I should not have an x. There we go. That looks much better. So now, so in fact, I'm just gonna. Oh, or this might be a definite integral because it's from 0 to t. No, it's indefinite. My bad. Okay. Then we have. Oh, wait. Oops. Okay, and then we simply have to solve this real quickly, and we get okay. Here goes nothing. Yep. Who would expect? Maybe like an algebra there, error around there. Oh, so it is definite. Okay. Oh boy. Let's do this. Life does not come without hard work. Hold on. Okay, no. I think I did most of things here right, in fact. What I only have to do is look at the things that I needed to apply the fundamental theorem of calculus to. So first, like this. Hmm. So, yes. So first, hold on. Oh boy. How long are we going in the live stream? We go 4 hours and 20 minutes. Plus an extra hour of watching lecture. So that's 5 hours and a half. I mean, we're actually kind of close, I believe. It looks as if we're kind of close. Oh, I see. Okay. So what we're gonna do. Think, okay, hold on. So so this is and why did I put a plus here? Bro. Yeah, it looks like it should have been a plus actually. All right, let's do this again. Oh, I really hate it when this happens, dude. So Right. Mm-hmm. Please. What the heck's going on? Because V of t is greater than this here. Oh, right. So done. Dt, y dw. Hello, please, bro. Now's not the time. Finally. plus though. Why, dude? It makes no sense. Oh. Oh, find the integration by parts again. So UV. What was U? U was V. Sorry, U was W. Or W squared. Oh, wait, no. Hold on. We actually have. U, V, right? Perfect. Hold on. One third. So shouldn't this that be one? U. Hold on. U, V. U, V. What's V? What's that? What's U? U is W squared. Why do I have 2W? Oh my gosh. Incredible, bro. Anyways, we have U, we have V. That's U. Is 2WV? Are you for real? Why? Come on. So what did you do? You did. Okay. But why only one U? I'm confused. Oh, so did we choose again? Oh my gosh, dude. You have du equal dw. Alright, I'm just gonna do double. I mean, I just finish quickly, man. We have negative 1/3 e to the power of negative 3 w dw, and that is du. V du. Okay, I understand that. But let's go. So now, so we have that. Hold on. Negative 1/3 t negative 3, and everything else is going to be 0. Right, it's going to be 0. Cool. So E, so what is, oh, awesome. Okay, so now this makes it much easier. Over negative 3, negative 3, minus hold on. So first, I'm just gonna whoops. There we go. Whoops, so that's gonna be 0, e to the power of 0, which is 1, I believe. Great. All right, what did we get wrong? But I put negatives, didn't I? Or is this, oh wait, hold on, this is gonna be positive. This negative? Negative, negative. So this is 1/3, negative 1/3, like that. Positive, like this, 1/3. e to the power of 0. That's 1, right? Yeah. Oh, hold on. Oh, no, so I was right at the beginning. Oh, okay, no, I was kidding. I don't know about that. So we did that. That's 1. Take these off. One third minus 1/3. Negative. Bro, at this point, what's right? So negative, 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 negative. Wait, t squared? Why is this a t squared? Should it be like that? Oh, wait, no. Yeah. I wanted this one. Did I miss a t? Negative 1/3 minus 1/3. Dude, at this point, I don't know what's wrong. I'll just have to ask. So first, it's negative 1/3. Okay, that looks correct. Then we have negative 2/9. And why is that? Because negative 1 times 1 is not 2. Negative 2/9. Maybe we have to multiply that somewhere. Okay. Okay. I'll have to be more careful next time. But... What? Oh, wait. Okay. For each of the following integrals, indicate whether integration by substitution or integration by parts is more appropriate, or if neither method. Interesting. Okay. X, sine of x. That looks integration by parts. This looks substitution. Well, both, actually. Wait. I think substitution for this one. And I think integration by parts because you have 2. That's substitution. Yeah, substitution for this one, I think. this integration by parts. Oh, that's probably substitution then. Okay, well, dude. I'll probably have to ask. I think I have to write intuition. What are the answers for the question above? In fact, no, not what are the answers. Can you explain how to there you go. When the integrand contains a function and its derivative. When the integrand is a product. Oh, I see. I see. No, it actually has a good point. So this is the integration of parts. Right. That's what I put, I believe. So this one is substitution. Okay. As well. Okay. Okay. Well, that is all fun and games. That is all very fun. Very cool. Well, now just gotta wipe the screen, make sure that nothing stays. No, thank you. Perfect. Awesome. I'll close that. Close that. Close that. Well, everyone, that was 4 hours and 51 minutes. That was almost 5 hours of math plus an extra hour of lecture, so that's almost 6 hours. I want to thank you all for watching this video, for watching this live stream. It was a lot of fun, but it was also very difficult. So I hope that you press that subscribe button, and I will see you all next time. Okay. I'll see you all. See you.